How many of you here have a rechargeable battery that you've ever had a problem with? Okay, most people deal with a rechargeable battery these days. And when you get into bigger rechargeable batteries and things like drones and scooters, and in fact, I think you're going to be seeing bird scooters appearing here very soon. And they are increasingly a problem in Raleigh right now for some of the things I'm going to talk about. And by the way, I'm with Triad Electric Vehicle Association. And let's see, I've been with them for 8 years, and we have a couple of other members here from the association. You're welcome to join us at our Saturday morning meetings that are usually at TS Designs down the road here. Still in the city of Burlington, right? Is that still in Burlington? Yeah, over by the airport. So one of the things I'm going to go over real quickly, for anybody who did bring a battery, we can analyze it and go through some of the tools I'm going to bring. And I'm going to do, I've been an academic and engineer for years, so I can't talk unless I have a script, and so the PowerPoint is my script. We'll just go through a couple of shared problem areas, and the kind of problems you typically come up with fall into one of 4 categories, so we'll go over them real briefly. And some solutions for that, and then actually, even if you don't have a battery, I have 4 tools over here, examples of the kind of tools you could use to rejuvenate your battery, separate from the kind of charger you get with your battery system. Usually the original equipment manufacturer charger, the OEM charger, is great as long as your battery is in good shape. As soon as you leave something, especially something that may have on the inside some circuit that's keeping something alive, those batteries often die and need to be charged every 3 months, but it's rare that the manufacturer actually tells you that. You find out when you've got a dead rechargeable battery. There are ways to revive them, and we'll go over that real quickly. So lithium-based batteries especially are the lifeblood of a lot of devices now. There are still a lot of older nickel metal hydride batteries around. In fact, the original Prius, one of the first hybrids, first large-scale hybrid vehicles in this country, was a nickel metal hydride battery pack. Some of those battery packs actually have outlived the cars. One thing about nickel metal hydride, if it's well cared for, it actually has a very long life compared to lithium batteries. I actually have an e-bike that came to me a couple months ago, and the owner could not get the battery to do anything. He tried several different chargers, nothing would happen. One of the chargers I had here, this black GT Power, which I can't lift up because it's actually running right now, which is a radio control lithium / nickel metal hydride multi-chemistry charger. After about a half hour fiddling, I got this 10-year-old battery pack on this e-bike back and running again. So a $3,000 e-bike is now back and running, where it was pretty much a piece of junk without that battery pack. So it can be really worthwhile to learn some of these tricks and learn some of these tools. Unfortunately, as a business model, it's got some problems with insurance, and I'll allude to that as we go on. Most of the tools, in fact, all the tools I'm going to show you, work really well with above 24 volt and above 2 amp hour capacity. So fairly decent sized batteries. Not what you find in your drills or smaller appliances. In fact, from that size and down these days are almost all LiPo, lithium poly, or some equivalent. Those are even trickier to deal with because there's a real significant chance of fire if you do something other than use the original equipment charger. So I don't fool around with lithium poly much. In fact, in the lower corner here is the kind of thing that happens if you put a non-original charger on it. You can see that bulge right there in the middle. Does this thing have a laser on it?
The green button.
The green, that. Right there. So here's what the device looked like normally, and here's what it looked like when somebody opened it up and had tried to use an external charger on it. Not a good idea to fool around with that type of battery. However, there are plenty that you can fool around with. One thing though, one rule of thumb I've had in working with batteries for decades is, if it comes in oozing or bulging, it's gone. We don't fool with those. And I strongly suggest, if you ever see any oozing at all, or even if you're looking at small rechargeable cells, if you look around the metal tabs where there clearly is a seal, if there's any kind of discoloration or little crystals forming, properly dispose of or recycle that battery. Don't try to fool with it. The 2 problems out of the 4 categories I had that really you can do something with is charge capacity dropping over time. a lot of rechargeable battery packs have a rated capacity. Over time, you get less than you had originally. That's actually normal internal wear and tear chemically. However, the amount of drop is what you can actually measure. And down here is a typical curve called a charge-discharge curve, where you can't see the lettering, and I can show you a bigger one over here on a laptop screen a little later. But at time 0, you attach a device that can just discharge your battery and measure current and voltage as you go along. And this is the typical kind of curve you get. Now this one actually was an electric bike battery. This, and I have one sitting over here, a Bionics battery, one of the most popular e-bikes, about 10 years ago until about 3 years ago when they went into bankruptcy. That battery pack still goes for about $850. And this and its mate were both dead. I mean, they were, one of them registered a half a volt and one of them registered 0. And this guy also had tried all kinds of different tricks on the web. I took one of these RC chargers and applied it. After about an hour, I had enough voltage. I really built it up very, very slowly using one of these RC chargers and got it to a point where that's actually the charge-discharge curve. I got it back to 75% of its original capacity, and it came to me dead. So this can happen. I'd say about half of the batteries I get, e-bike batteries, I can get back to 50% or greater capacity. Usually the peak is around 80. You know, I haven't gotten one greater than 80% capacity yet. Yeah.
Is that due to a buildup on the anodes, or is it a degradation of the anode?
Hard to tell. Hard to tell externally. Without actually cutting them open and examining them, it's very hard to tell. There are a lot of different ways rechargeable batteries over time can't achieve the same capacity they did originally.
So there's nothing you can do to, like, put a reverse charge on it to undo it?
No, with lead acid batteries, yes. There are a number of tricks and there are a number of chargers available that will run a trickle charge and run actually an AC current through the battery, and they will actually clean off some of these dendrites off of the lead plates. That's an old, well-known trick. I think those came into use when I was in grad school, which would have been late 70s. I remember those circuits appearing in trade journals, and of course I was in a power engineering program and we dutifully tried them and found out, yeah, not only do they work, we could scale them up. Some of the bigger UPS batteries we were working with manufacturers of uninterruptible power supplies. So there are techniques that have been around for decades. They will work with certain chemistries. With other chemistries like lithium, they don't work. Not only do they not work, don't plug a lead acid battery charger into a lithium or a nickel metal hydride pack. You're almost guaranteed to destroy it in fairly short order, mainly because of this funky thing it wants to do, float charging and this restorative charging. That actually will destroy lithium cells. Now, one of the tools that most commonly used to analyze your battery is some kind of a computerized battery analyzer. This is one of the most popular of the non-professional tools. So a lot of hobbyists, ham radio operators, people who are working with smaller devices like e-bikes and scooters and such have one of these things. And I have one over here. West Mountain Radio is a ham radio supplier and commercial radio tool supplier. And this tool was developed because a lot of ham radio guys have gel cells and they let them sit and they use them 4 times a year, and you can't do that. And so finally we started, over the years, built up tools like this, and West Mountain Radio said, there are about 6 or 7 different of these designs. Maybe I can come up with one and sell it that's a reliable, repeatable version with the same kind of tests. And this product has been out in various incantations for about 15 years. So this is on the 4th generation right now. And this has an associated software that will allows you to hook up and quickly develop these curves. Now it takes a long time. This is a discharge curve. I usually put some notation here, which is a little hard to read, but I think that's a 1 amp. I think that's 1 amp discharge, fairly slow discharge. So on this 9 amp hour pack, it took about 9 or 10 hours for this charge curve to develop. But this is essential to hand to somebody, brought in this wonderful e-bike battery and they want proof that it now works aside from putting it on their bike. Putting it on your bike, it's kind of hard to tell what is the real capacity of the battery. Doing this kind of measurement, you can really tell. What I'm hoping to do at some point in the near future is make some of these tools available more broadly so that people in the community who have that kind of a need, we can, at a place like Steam Junction, have you come in, start running that tool in a nice space like downstairs with the right kind of packaging. One of the things you have to do if you're doing this kind of testing is have a fireproof something to put the battery in. Although it's very rare for LiFePO type batteries, which are in e-bikes, to catch fire, the little bulging pack you saw in the LiPo kind of battery, that happens enough that it's of concern, especially to insurance companies. So using this or the larger version of I've drilled holes into those fire safes and put wires in them, and then we close the safe and let it run for a day and a half or whatever it needs to run. That meets the test for most insurance companies who actually query, gee, what are you doing downstairs in that battery vault of yours? Oh, and back to the last one, I was going in the inverse order. The most common problem is you can't charge your battery or batteries at all. You know, you buy this wonderful, expensive e-bike, and these days every major chain of bike shops will sell you an e-bike. Typically the minimum is $1,000, and they go up from there. I just was over at the bicycle chain, which is Durham, Chapel Hill, Raleigh area chain. And they now have a series of e-bikes, and the high-end one is $4,500. And this is a bicycle, $4,500 for an electric bike. Now, what they don't have yet is anybody local they're working with who can do this kind of analysis on the batteries. The company and all the e-bike companies right now, if you bring in your battery pack with a problem, ship it back to the company. Actually, there is one exception, Pedigo, who doesn't sell anything less than $4,000. They do allow their local guy to open up the battery pack and do some diagnostics. That's the only exception I found among the industry. All the others insist, send the battery pack back. Usually they're going to charge you some hefty charge, and $500 later, you got another battery pack.
So
I think this is a bit of a ripoff, and a bunch of us who've been working in this area think we can do better with local tools, local analysis, and essentially restoring those batteries. Good.
So I suppose though that if someone's into that, it's for hobby or for real practical use, that motivates them to then buy 2 or 3 battery packs.
Yes.
As backups, so that if one goes bad, they always have one while they're shipping the
Yep, that's the first upsell for every e-bike. If it does have an external battery pack, and there actually are a couple that don't, that it's internal and highly reliable, and you send the bike back. But there's one OptiBike. Actually, if you've looked at the Pikes Peak has a hill climbing challenge every year, and the current winner among small electric vehicles is this FFR trike from Asheville area. But prior to that trike, which is essentially is a platform with batteries, essentially the whole thing is battery. You're sitting on top of an enormous battery pack with 3 wheels. All right. The only thing in a way of a bicycle that's ever competed with it is this thing called the OptiBike. And that was the one that I said came in with the nickel metal hydride battery, did nothing. Well, I revived that, and now I have an OptiBike because I bought it from him for thinking I could get it to work, and I did. So I now have a $4,000 e-bike with built-in, you can't take the batteries out. Well, it's very hard. All the other manufacturers try and upsell you by selling you a spare pack. The typical pack costs about $900 to $1,200. Yes, so that's on a $2,500 e-bike. The battery pack is typically around $900 to $1,200, almost half the price of the bike. So that gives you an idea of why this is an opportunity to help the bike technicians in the area who have been reluctant to deal with e-bikes in the first place with this enormous problem of the expense and the lack of repair capabilities on the battery, the #1 failing component. Now, if you're in an electric vehicle, commercial electric vehicle, whether it's Chevrolet in the Volt or Toyota in the Prius or all the others around, they do a lot of diagnostics on their batteries before they ship them out. And they will often go down to the, some kind of unit level, like a few cells, pull them out and put them back in. Now, they're usually a regional place that can do that. Unfortunately, when you go down to things like a bike or motorcycles, in fact, on that motorcycle, the motorcycle,
yes, the Zero.
the newer Zeros, do they actually work on the battery packs, or is that still you send them back?
Don't know for sure.
Don't know for
I do
sure.
know the newer ones have a removable pack.
Yeah.
So.
Yeah, so motorcycles, there are increasingly more electric motorcycles available. Little different territory, unit territory, where now you're talking $15,000, $20,000 starting prices. So they typically do have more in the way of warranty support around all components, including the batteries. Bicycles are in this funny categories, and scooters are even worse. Have any of you seen these Bird scooters around? They're in Greensboro and Charlotte and Raleigh. And I'm told they're coming to every town greater than 5,000 people in North Carolina within the next year. You will see them. And they will populate all over the place, because you essentially walk up to it with an app on your phone, and you can then, if the app's working, you can then schedule a ride on this scooter for, it's $1 an hour, I think. So you can pop on the scooter, go wherever you want, and then you just leave the scooter. The whole business model there is very funny, because here you've got about an $800 to $1,000 scooter, and they're just all over the place. At this point, in Washington, D.C. and especially, there's a depot of Bird scooters. The number one problem with them is the battery packs. And they don't have enough technicians to go through and even screen them to figure out what to do yet. So we actually have a proposal in the Bird, we being the Light Electric Vehicle Association, which works with TEVA, to work with Bird. We got a proposal on what to do with these scooters. However, we don't have enough people to actually do that who are trained yet. So we actually do a training that's coming up in Danville in September for e-bike technicians, and we're probably going to have a Bird scooter there too, because Bird, if you haven't heard them before, is a $2 billion company within a few years. $2 billion of scooter rental, which boggled my mind when I heard this last month. Couldn't believe it. So there are opportunities here for people to actually do this kind of work of refurbishing batteries professionally. Got to this point now, this presentation is meant as kind of you work through it, and if you have problems then we help dispose of your battery securely, safely. If you have 2 or 3, probably help you right away. If you have 1, we see if we can help you at least walk out with something that will now charge. And that's actually been the way I've worked in smaller exercises like this before, is try and get somebody who brings in their battery to a point where their charger at least picks up and starts charging that battery. So they've saved $500 to $900 just by working with us for a half hour. Oops. And so I think the last is, here's some pictures, and I can actually show you the units over here. This is a fairly typical one. I've been using this GT Power A8. This is actually still my favorite for restoring a battery pack. It was developed and sold primarily on Hobby King and other sites like that for the radio-controlled drone industry. And this has a very basic output, and what you see under it here is actually just a ham radio power supply. I'm a ham radio operator. Anybody who's a ham radio operator has lots of power supplies laying around. So turns out the GT Power is very nice in that they designed all their units so they can work with a ham radio power supply. You don't have to have a fancy one. Unfortunately, the next one up I'll show you does have to have a fancier supply than what I have on hand. So a $50 supply from a Hamfest, and this, and you're in business for up to, and this is up to 8 serial cells. So if you're talking lead acid, we're talking 24 volts. And now 24 volts, 5-6 years ago, was pretty common pack voltage for scooters and cycles. The scooter, if you saw that Curry scooter running around at the Maker Faire this past year, that was a 24 volt Curry scooter. In fact, I have the 2 battery packs from that scooter over here, if you want to see the difference between the lithium version of it and the gel cell version of it. In fact, there was a whole movement around coming up with gel cell replacement form factor batteries, but with lithium cells on the inside. And I have a few of them, 2 of them in a pack and 1 of them separately, and you can actually see them. For some reason, that didn't fly very well. They work well, but too many people had lead acid gel cell chargers that did the trickle kind of phenomena, and it just shot the cells. There was no protection in the battery that could say, oop, if I get to that mode, turn off, don't charge. So it did ruin a few cells. So this is what you see on the screen. Here's actually that lithium gel cell format pack over here. You can't quite see the screen, so I put it over here. You see this is a lithium ferrous phosphide, LAFE, and it's 8 serial cells, which is nominally around 26 volts, but yeah, 24 volts plus or minus, right? And here's actually the charge graph on this thing. This is actually from the screen of the slightly fancier one. But it's showing you the basics of as it's charging, you get a display on the screen of these things. And then sometimes they give you a little graph so you don't actually have to hook up a PC to it. That's kind of a nice single unit charge-discharge controller. This one I've had for 4 years now. The screen is actually from the newer one that I'll show you over here too. That one I just got earlier this year as I'm going into higher voltages. So most of the newer bikes are 36 to 48 volts, and actually they keep climbing every few years. And as you get to higher and higher voltages, it turns out the chargers are more and more expensive. The multi-chemistry chargers get more expensive, and you need higher voltage power supplies, and the whole process of keeping up costs a bit of time and money. Now, there is one other device that no, I've got a bunch of references here. There is one other device that I've got not running here. Each industry, like electric bikes, has really, really top-notch innovators these days. Some of them are really, really tiny shops. This one is from a company, it's ebikes.ca, a Canadian company, and they put out a thing called Cycle Analyst, which everybody who has a meter on their electric bike has either Cycle Analyst or a proprietary version of it. I mean, 90+% of the bikes. And the guy, Justin Taylor, who founded that company, also realized that this charging phenomenon is a huge problem for most of his customers. What can they do about it? Well, they took all the electronics I showed a second ago, and I put down the remote. And the picture here, so you have the power supply, you have that thing, and you can see these are custom-made jumper cables. If you get into this business, you're going to solder a lot. Solder and crimp a lot, because inevitably, whatever battery pack you get or whatever new e-bike has a different connector on it. And I swear, I have at least 50 different connectors for different kinds of batteries and scooters and whatnot. There are a few common ones that are sort of industry standards. But by and large, you just have to convert from one to the other. Well, so Justin decided, okay, the Curry connectors are pretty standard. Anybody who has something other than the Curry can make an adapter for it. I'll assume that part can be handled. And I'm going to build in everything that you need on e-bikes from about 8 years ago to today in one box, at least for the charging part. This doesn't do the discharge analysis I talked about, but it does the charging part. In the radio control world, those boxes all do both. I really like these boxes. Not only do they do both, they have all kinds of settings, and the amazing number of settings you can do with 4 buttons. 4 buttons and no computer control. So if you love pushing of buttons years ago and programming things, you'll love these things. Justin took a little different approach. Created profiles, you can go to a PC, update your profiles, and then attach the battery pack from your e-bike, and poof, even if it's dead, there's a mode that essentially says it's dead. You press a button, and it tries to revive it. And it goes through a series of processes, much like what I've been doing for years with this box, to revive your bike battery. The 3 I tried it on that had been sitting idle way too long in my garage, they all worked. And I'm saying, So less for me to do these days, less for me to teach with these kind of devices, but this little thing doesn't come cheap. That little box right there, about 65 bucks, and it'll work on anything that's 30 volts or lower. And the power supply, something on the order of 25, 30 bucks. This little thing is 300 bucks, and then you pay more for the cables if you want them to do the cables. So if you're really doing this a lot, these things are great. If not, and I've been writing some of this stuff up. There are a few places called V is for Voltage Forum, and there's another one, Endless Sphere, where people have been putting these kind of hints and tips up for years. For whatever reason, nobody's written up a little guidebook. So because the Tiva group has a fellow who's been working on developing these classes for e-bike technicians, we're going to add a section to that tutorial for e-bike technicians, a section to what's called the Electric Bike Maintenance Manual, EBMM, and we're going to make it available to anybody who's interested. So you won't have to take the course to get these, the information on these tutorials. And we're going to work to make the tools available to anybody who wants to borrow them. We would prefer to enable you to borrow the tools and do it yourself. For liability reasons, it means I don't have to carry a $2 million umbrella or something like that. And also for safety reasons, if you can do it safely in your home with your bike and your equipment, you're better off than trying to take everything to somebody who's going to do it who doesn't know the condition of the battery. So hopefully that'll be a win-win all the way around. As I say, there are more references here if you want to look them up. So everything here, all the hardware, and we had a little disclaimer here, nobody brought in a battery, so I'm not going to worry about that. A couple of other tools that I think are essential, and if you're working on power technologies, there's a little difference than if you're working logic levels. And there are a couple of things you really ought to have. One of them is deoxit. Has anybody ever heard of this stuff? Okay, you got to have it if you're working with any kind of power levels. Put it on every contact you put back together. EV guys have known this for years. And there's actually another brand. What's the other? There's one other competitor to this, Gold something. So deoxit, and there's two manufacturers of this kind of compound. Basically what it is, it's a treatment for electrical contacts, and it does enhance the conduction of the electrical contacts. It minimizes corrosion and all that good stuff. There's greases, there's sprays, and there's all different kinds. There's about 10 different variations of this. The most common is the red deoxit D series stuff.
You good for a car?
Anything electrical that you have to make a contact with, there's actually a grease for cars that's better than the spray. Yes, I highly recommend them. They're not cheap. This can's 20 bucks. And the little teeny tubes you see are about $5 a piece that have like an ounce and a half of stuff in them. But well worth it. It has saved me many times over from having to rebuild a pack, just having made sure that when I built it, I put as much of this stuff as I could tolerate. And that's all I had. If anybody's interested in seeing the equipment, I have several batteries under power here, and I can talk about the equipment in practice here. But any other questions? Yes?
The deoxit, do you spray it on and it cleans, or you mechanically clean and then spray it on for protection?
The latter. Mechanically clean, and they do come out with some of the solutions are meant to be used to enhance cleaning process, so 3-step if you will. And some of them can do both. The red series does both.
The contact cleaner that we'd spray in like potentiometers and things.
Right, and the contact cleaner was great for giving you a one-shot, we clean the wipers on potentiometers and everything. There's, I don't know what the compounds are in here because that's actually company proprietary. And whatever it is, coats it really well, a lot better than those contact cleaners. No, it's not water. No. And both of these are on the GSA schedule. So the military uses both deoxit and whatever the other one is, I can't remember, and they've had good results with it. And I suspect they pay a little more per ounce, but at least it has been validated in military, ruggedized environments too.
And the can will last you a long time.
Oh, a long, yes.
It doesn't take much
It's a little squirt, yeah.
to do it.
Yeah.
It's great for video and audio connections. No.
Yeah. And while I have the floor, there's one other pet peeve I have. If you're working in, well, not just metals, soldering and stuff, you often have to use canned air. I hate canned air. I mean, I hate canned air with a passion. And there's a company called Hurricane, or actually O2, I think is the name of the company. And their latest product is the X3 Hurricane. And this is canless air. So it replaced those damn canned air. It's rechargeable in the same form factor as the can. And in fact, I have it on one of these little lugs that goes on my thing. No. It's got a nice little lithium battery in the bottom. In fact, this one is supposed to be 200 miles per hour exit velocity, which is approximately the same as what's coming out of canned air. The last version was a little bit lower. They finally got it up in the same package, so I bought one of the new ones.
And you don't freeze your hand.
And you don't freeze your hand off. It is a little bit noisy, but for ecological reasons, my wife's an environmental educator, and when she saw this, she said, "Oh, good, no more canned air." So that's the last thing I'll mention. So,
How much is it?
oh, that little, I got it on eBay for $65 in a auction. I think they actually retail for $130, but you see them going all the time on eBay for half price. Yeah.
You talked about the problem of starting fires.
Yes.
And you want to keep it in a contained environment.
So you don't start a fire. Yes.
But the whole problem is cooling it off so that you're not having. So I'm wondering how you have the
Okay.
trade-off between insulation value versus insulation.
Most of the problems with all the lithium compounds and any fire is oxygen. It's not heat. So once they get warm and then you have any leak, it's lithium compounds coming in contact with oxygen. If you can minimize that in a little bag, that's what and actually snuffs out any of the
Catch on fire,
reaction.
they don't go out until they burn themselves.
If they do catch fire, the whole thing is keep them from catching fire. This is one of the most popular. There's a set of bags on Amazon, eBay.
I sell them at my store too.
Oh, you sell them at your store? Okay.
Yeah, I work.
And the bag locks, it has a key.
Oh, that's from the battery pack. So I got those. Now you're required, if you ship lithium batteries, to have either one of those or the special package, the special box packaging that is flame retardant, one or the other. I found that was actually cheaper, and since I get them shipped back to me, I get the bag shipped back, usually, most of the time. So any other questions? Yes?
I know in the past drill batteries have mostly been repairable to some degree. The D-type batteries put in. Now on the new e-bikes, are the batteries, they actually have repairable parts such as like individual cells. Is that how
Okay.
they're repairing them, or are they just mostly?
In a special
Replace.
environment, they can be repaired, yes. The bulk of the manufacturers, if they get them back, don't. So what they often will do is they'll sell them out to scrap companies who will then they'll break them apart and resell the cells as refurbished cells. So you get these that are called 18650, which is actually just the configuration of the cell, and they'll say what the capacity was, because usually they'll test them with a charger like this, and you'll get the cells back. But I'm not aware of anybody who rebuilds e-bike battery packs at this time. There are many folks who will rebuild a pack for a drill, a nickel metal hydride, or even NiCad drill, but not lithium. I haven't seen the lithium.
Is it because the cost of the cell is so cheap in regards to what the labor of a technician would be? Is that?
It's part with nickel metal hydride. The markup is such that you can actually get a rebuilt pack for cheaper than a new pack. With lithium, the problem is around the safety aspects of a process to rebuild. So the requirements, at least in this country and in Canada and Mexico and all of Europe, are such that you have to be an ISO 9000 kind of a shop with those kind of safety and security safety precautions in order to actually rebuild those packs. So there were places in China that were rebuilding for a while. They stopped. They decided, nope, we'll take them apart, we'll resell the cells, and that way whoever is building whatever is actually building it from new. They're just using refurbished cells, but they're not trying to take apart a pack and avoid that bad cell.
And the rebuilt cell, does it essentially still have the same strength as a new cell?
They'll characterize them and tell you that it's a 2.1 amp hour cell, where originally maybe it was 2.5.
Okay.
So they will go through, and automated testers like this are readily available on the market, and they just essentially put them in a tester, and it comes out with the test results on each cell, and then they'll be sorted out, and that way you'll buy them in lots, and that's pretty typical. So they don't rebuild the pack, but they'll take it apart, take the cells apart, and then they'll resell them as refurbished. Because often what happens is in that pack, there's one or two cells that went bad. And they're arranged in such a way that there's usually at least 4 redundant. So through any electrical path you take, there's 4 redundant, there's 4 in parallel. If one goes out in any of those sets, you're okay. 2 goes out, you're at least your peak current capacity went down, and your peak energy capacity may have gone down, some percentage, but they're still usable. As soon as a 3 goes out, then you're dead. Then it's time to give it to the refurbishers or to the guys who take it apart. Yeah, Lee.
Is there possibly an opportunity to provide a service to recharge and service these kind of batteries?
Absolutely.
So the question that I have is that because I'm not a user of electric bikes and vehicles, although maybe for hand tools and yard tools and things like this, the question is, I guess, what would be the market or volume? I mean, how many people are using these things? Is it like 1% of the population or 5%? I have no clue.
Nowhere near 1%. Of the bicycles sold last year in the U.S., which is something on around 200 million. I was like, really? 200 million bicycles sold last year? Okay. The electric bikes are about 2% of that.
Okay.
So that's 2%. Yeah, it was around 40,000. Right. Oh, wait a minute. 400,000. Which is still, it sounds like a pretty big number, but they're scattered all over the country.
Right.
And that's not high enough density. And because E-bike, there's no standards right now. The one thing you get if Chevy does a pack on a Volt, then they probably keep that package, that battery package, fairly similar for about 5 years. So there are refurbishers that refurbish Volt and Prius packs because they've stayed fairly similar for 5 to 6 years. You can build a business model on it. E-bike manufacturers, and for some crazy reason, come out with a new configuration, even the same bike, same model line, another year, it's a different configuration battery pack. Why they're doing this, I don't know. It's like the turn of the 1900s in cars.
They've been doing it for years with bottom brackets and standard bikes. So
Yeah.
look at the standards out there. It used to be 2. Now I think it's something like 12.
And so bikes, for some reason, have evolved in a very different way than, say, cars, where there's this innovation that happens and they just don't pay attention to standards, which kills you when you're trying to do something like refurbishing battery packs or at least revitalizing them. It's a very difficult business model, small volume, lots of variation. Once they get to, there was one point about 10 years ago where Curry dominated the market. So it was a 24-volt lead acid, and occasionally you would see a nickel metal hydride version of it, battery pack dominated for about 3 years.
So the little scooters that you see seniors or those who are disabled in the stores and stuff like that, you see them in Walmart, grocery stores, and various places, sometimes just scurrying around town, these little scooters. Those are electric, right?
Those are electric, and they're almost all gel cells. They're almost all lead.
Okay.
In fact, they want lead. They want heavy in the bottom. They want stability. And those are lead acid battery technology is pretty easy to deal with.
If those were even nickel hydride, then that would increase the.
It would.
That would increase the number.
It would. You would think that this is an opportunity for the e-bike industry and the scooter industry to collaborate. And even the little scooters like the Bird scooters. You would think at one point they would want to collaborate to get common parts and common process for. No, not yet. Not yet.
I was trying to bring a lot of my coffee buddies here tonight, and they had a very antiquated perception of scooters and e-bikes. It was the one in which you drum up pictures of things that we saw back in the 70s and 80s.
Okay.
So not even in the last 10 to 12 years. And I thought, they said, oh, that's got to be very unsafe. And I'm going, your vision is pretty small because we're going to be having, you might think of it as just like robotic assist vehicles that help people walk, get around. It's not necessarily for traveling across town anymore. So with that kind of a need, that's the future. So if that's the future, one needs to ask the question, okay, lithium ion gives you a lot more, those kind of nickel hydride or metal hydride kind of batteries do give you more punch for a higher energy density.
Right.
Well, what's around the corner that may really push it forward?
There is research on different kind of anodes and cathodes. There's nanocarbon electrodes, and I've seen results. There were a few patents that were just processed 2 years ago that talk about 2.5 times the energy and power density of current lithium ferrous phosphate. So, I mean, that's going to be a tremendous boost. We're going to see them soon. We're going to see all kinds of these little things that are going to be assisting us. I mean, imagine every walker that's around and imagine it motorized.
Well, if you have a power chair, like we do, a scooter power chair, our goal is to not to upgrade it to anything else, is to keep the darn thing going.
Okay.
To avoid having to spend money to replace the battery in the first place.
Yep.
So, and I don't know whether it's.
So what we'd like to do is give you that enhanced energy density and power density by being able to put the modules in the battery, replace them with this, which instead of being a gel cell is lithium ferrous phosphate. And the next generation will be these lithium manganese or lithium cobalt, which are even denser in power and can replace what you've got.
But I don't want to do that. I want to keep what I have going for as long as possible because it works.
And you will be able to, but lead acid has a lifetime, typically 2.5 to 3 years in constant use, and then there's just nothing you can do with a gel cell. It's dead. Now, yes, these twice the life for 3 times the cost. Oops. Yeah, you heard it right. You heard it right. Twice the life, 3 times the cost. Something's out of balance. And there are ones, yeah, there are ones 4 times the size. In the scooters, the problem is they're not heavy enough because the scooter assumes that weight for ballast. So you got to put dead weight in if you put these new batteries in. Okay, different problem. But those are coming. Solutions like that are coming. And what I think is an opportunity, especially as we get more and more customers, consumers demanding that these things be fixable. Because one of the things, and I love this poster I saw about the right to have the ability to fix your device. This is in that category what TEVA and this Light Electric Vehicle Association is doing with this set of courses to help. We're targeting bicycle technicians first, mainly because that's a fairly large audience, and the companies who, right now there's a consolidation, there's about 10 big bicycle companies, all of whom Don Gerhardt has contacted. It's like he wants to be vice president in every one of these companies, I swear. And he now has the agreement that we're going to put appendices in our electric bike maintenance manual for every one of these manufacturers. We want to, and some of the community colleges we're working with want to branch out and do more than just bikes. And that's the next step. That's the next step. You know, I've been passionate about enhancing this technology for years.
What is that battery?
You can see that. So that is it.
It's a lithium.
Yeah, and I can show you, I have 2 battery packs from the scooter that was running around. I think it was Ilse was mainly using that thing, right? The scooter she was riding around at the Maker Faire had 2 battery packs. One of them lithium, and one of them a gel cell based. And you can come and see this, the lithium has higher capacity and lower weight. But the lithium packs, there were 2 of those things in it. Those are $100 a piece. The gel cells that are originally in there are $20 a piece. If you got a scooter, which one are you going to do? Unless you're an idiot like me who's playing around with batteries, you're going to buy the gel cells.
Replacement batteries for ours, I think it's about $200.
Okay, and the replacement, if it were that, is probably going to be about $500.
So which kind was it that was in the machine?
You had both. You didn't know. I kept switching them out, and I was waiting for you to tell me there was a difference between the 2.
No, I never noticed it.
Yeah,
Wow.
that's the proof point.
That was my question, is just, does a lithium pack a better punch? Or is it just?
In this case, it didn't, because the cells were actually not really highly rated cells. They could have, but this was not a high-end lithium cell in those packs. So it was a medium-grade lithium cell. In fact, I was overrating it a little bit to use in that Curry scooter, but it was on flat, so I figured it was going to do okay, and it did.
I guess the issue is one of economic versus technological needs, because, for example, like in drones, well, I mean, you sort of have to have something made out of lithium in order to get off the ground. So it's worthwhile to pay the extra price per energy density.
Yes.
But for something like a scooter,
It may not. No.
it probably isn't there yet.
I think the driving factor in e-bikes making the transition was when the cost for the pack was twice the cost of the lead acid pack for at least 1.5 times the performance. That was the point at which they said, okay, now people will buy it. And they did all kinds of studies, and they came up, that was the point. And when the lithium technology reached that point, in the size battery pack they need in electric bikes, that's when you saw the switchover. Not until then. And still, it's a price premium. But if you look at the total cost per life cycle, it came out to be a wash because the life cycle was 2 to 2.5 times longer life. That's a hard sell to people. But if you have like a scooter and you've had it for more than a couple of years, you will notice that it will degrade. It will start degrading. I guarantee you if you used it every day. And if you had one of these inside, it would take 2.5 times.
You say there are things that you can do to improve it.
Yes, you still could improve SLA batteries, gel cell batteries. There are some things you can improve, and I can talk to them. We won't hold everybody on that, but I can talk to you about that. There are charges you can get that will actually do a, it's a charge that actually knocks these dendrites off of the cells inside the batteries. And it can improve a gel cell's life by another year, 50%. Okay? I can go on like this forever, so yeah.
All right, one quick question. Now, the e-bike industry, do you guys have some sort of education by also battery voltage cutoff, or for the devices so that the user is not going below 3.5
Battery University.
per cell? And, okay.
BatteryUniversity.com. Everything you want to
The
know.
drone industry is a big problem because a lot of it, new users,
Yes.
they deplete the battery, to the point that it's just not usable again. Right?
This was started, as I recall, by folks who were working in, it was light electric vehicles, but it wasn't bikes. I can't remember what platform. They started Battery University, and there are a lot of people from RC who have contributed to Battery University. That's the go-to place if you want to understand the different battery technologies, especially if you have a particular, like an unusual battery chemistry, like a lithium cobalt. There are lithium cobalt batteries out there, but most of the chargers don't have a profile for lithium cobalt. But you can go and look at the characteristics and say, okay, oh, that's very similar to lithium poly. So it means the setting lithium poly on that charger will work for your lithium cobalt battery. That's the kind of thing you learn from going to Battery University. Okay, so thank you all very much for your attention, and I got all kinds of things you can come look at here if you'd like to. Thank you.
So Mark, again, when are the TIVA meetings if folks want to get in?
Oh, so if you're interested in the Triad Electric Vehicle Association, we meet the first Saturday of every month, usually at TS Designs. Occasionally we go somewhere else, and we always post it on the website, which I didn't put it up there, oops, is tivanc.org.